Hello, and welcome to Astronomy Daily, your source for the latest news and discoveries from the cosmos. I'm Anna, and I'm thrilled to have you join me today as we explore some fascinating developments in space exploration and astronomy. Coming up on today's episode, we'll be tracking a historic moon landing attempt as Japanese company Ispace prepares its Resilience lander for touchdown on the lunar surface. Then, we'll look at Russia's plans to integrate their homegrown AI system into the International Space Station. We've also got an incredible discovery from the James Webb Space Telescope. And finally, we'll get an update on SpaceX's upcoming AX-4 mission. So much to cover today, so let's get started with our cosmic journey. Tomorrow could mark a significant milestone in the history of private space exploration, as Japanese company Ispace attempts to land their Resilience spacecraft on the moon. This mission, scheduled for Thursday, June 5th at 3:24 p.m. Eastern Time, represents a second chance for Ispace following their first attempt that unfortunately ended in failure last April. The Resilience lander, also known as Hakuto-R Mission 2, has been on quite a journey since its January 15th launch aboard a SpaceX Falcon 9 rocket. Unlike some lunar missions that take a direct path, Resilience followed what's called a low-energy transfer route to reach the moon, which is more fuel efficient but adds months to the journey. After this lengthy voyage, the spacecraft finally entered lunar orbit on May 6th and is now ready for its landing attempt. The target landing site is in Mare Frigoris, or the Sea of Cold, located in the northern hemisphere of the moon's near side. It's worth noting that this is the same general region where Ispace tried to land during their previous mission in 2023. However, the company has backup plans in place with 3 alternative landing sites, should conditions change, each with different landing dates and times. For those of you interested in watching this historic event live, Ispace will be broadcasting the landing attempt on their YouTube channel. The live stream begins at 2:10 p.m. Eastern Time, about an hour before the scheduled touchdown. They'll actually be offering broadcasts in both English and Japanese, so you can choose your preferred language. What makes this mission particularly significant is that, if successful, Resilience would become only the second private spacecraft to accomplish a soft landing on the lunar surface. The first was achieved by Intuitive Machines' Odysseus lander back in February, though that landing was somewhat precarious when one of its legs failed to deploy properly. The timing of the landing is especially challenging because of the 1.3-second communication delay between Earth and the Moon. This means the spacecraft must handle the most critical landing maneuvers autonomously, adjusting to the lunar terrain in real time without direct human control. Once Resilience successfully touches down on the lunar surface, it'll begin a relatively short but intense mission. The lander is designed to operate for about 2 weeks, essentially 1 lunar day, before the harsh lunar night brings operations to an end. But don't let that short time frame fool you. There's a lot packed into this mission. Perhaps the most exciting payload is the Tenacious microrover, built by Ispace's European subsidiary. If all goes according to plan, this small rover will deploy from the lander and begin exploring the immediate surroundings. It's equipped with a camera and a sample collection shovel that will test capabilities for future sample return missions. The rover is also carrying something rather unusual for a lunar mission, a work of art called Moonhouse, which is a small red house designed by Swedish artist Mikael Genberg. And in a nod to pop culture, Resilience is also bringing along a commemorative plate with an inscription based on the Charter of the Universal Century from the popular Japanese Gundam series. In some rather interesting news today from Russia, the country plans to integrate its homegrown artificial intelligence model called Gigachat into the International Space Station's IT systems. Roscosmos chief Dmitry Bakanov announced that the next mission to the ISS this northern autumn will deliver everything needed for the AI to function in space. This isn't just about having a space-based chatbot, though. The Gigachat model will have practical applications, specifically helping cosmonauts process satellite imagery. According to Bakanov, it'll increase the maximum resolution from 1 meter per pixel to 0.5 meter per pixel, which he described as direct assistance for the cosmonauts. Gigachat was developed by Sberbank, Russia's largest bank, and represents one of the country's flagship large language models. It's part of Russia's broader efforts to catch up with the United States and China in what many are calling the global AI race. The timing is interesting too, as Russia has confirmed it will continue participating in the ISS until 2028, even as they develop their own new space station. They're planning to launch the first two modules of that independent station in 2027. The next Russian spacecraft mission to the ISS is scheduled for November 27th, which is likely when this AI technology will make its way to orbit. Now to what might be one of the most exciting astronomical discoveries of the year. Scientists have detected crystalline water ice around a young, sun-like star for the very first time. This groundbreaking observation, made possible by the James Webb Space Telescope, gives us direct evidence of something astronomers have long theorized but never directly observed before. The star in question is called HD 181,327, and it's located about 155 light-years away from us. What makes this discovery so fascinating is that this star is essentially a baby version of our own sun, just 23 million years old compared to our sun's mature 4.6 billion years. And unlike our solar system, HD 181,327 is still surrounded by what's called a protoplanetary debris disk, basically a ring of dust and ice that hasn't yet formed into planets. Using Webb's near-infrared spectrograph, researchers from Johns Hopkins University were able to identify crystalline water ice in this debris disk. This is the same type of water ice found in Saturn's rings and in icy bodies within our own Kuiper belt. According to the study's lead author, Chen Zi, this water ice plays a vital role in planetary formation and could eventually be delivered to terrestrial planets that might form in this system over the next couple 100 million years. What's particularly interesting is the distribution of this ice. The JWST data shows that over 20% of the debris ring's mass consists of water ice mixed with dust particles, what astronomers colorfully call dirty snowballs. This composition is remarkably similar to our own Kuiper belt. And there's a clear pattern. The closer you get to the star, the less ice you find. At the disk's halfway point, ice makes up only about 8% of the material, and near the center, there's virtually none. This pattern likely exists because ultraviolet radiation from the star vaporizes ice in the inner regions. It's essentially giving us a snapshot of how water might have been distributed in our own solar system during its formative years, potentially helping explain how Earth and other rocky planets eventually obtained their water. Looking at the distribution of this water ice in more detail, we're seeing a fascinating pattern that tells us a lot about how planetary systems develop. The JWST data shows this ice isn't evenly spread throughout the disk. It's heavily concentrated in the outer regions, similar to how our own Kuiper belt contains most of the icy bodies in our solar system. What's really interesting about this finding is how it supports our understanding of planetary formation. In the outer regions where it's cold enough for ice to remain stable, we see these dirty snowballs forming, mixtures of dust and ice that can eventually clump together into larger bodies. This process is likely how the ice giants like Uranus and Neptune formed in our own system. But the pattern also helps explain one of the biggest questions in planetary science. How did Earth get its water? Since Earth formed in a region that was probably too hot for water ice to exist initially, scientists have long theorized that water was delivered here later by comets and asteroids from the outer solar system. This observation of HD 181,327 gives us a sort of snapshot of what that early delivery system might have looked like, with icy bodies from the outer regions potentially migrating inward and bringing water to the forming terrestrial planets. Finally today, a small update. The launch of the AX-4 mission to the International Space Station has been pushed back again. Axiom Space announced just yesterday that they're now targeting next Tuesday, June 10th at 8:22 a.m. Eastern Time for liftoff. This is actually the second delay for this mission in recent weeks, as it was originally scheduled for May 29th before being moved to June 8th, and now it's been pushed back another 2 days. This private astronaut mission will fly aboard a brand new SpaceX Crew Dragon capsule, launching on a Falcon 9 rocket from Kennedy Space Center in Florida. And I've got to say, the crew lineup for this mission is particularly noteworthy. The 4-person team is led by Commander Peggy Whitson, who's honestly a space legend at this point. She's a former NASA astronaut who holds the American record for most time spent in space. Now she serves as Axiom's Director of Human Spaceflight, and this will add even more spaceflight experience to her impressive resume. What makes this mission truly historic, though, is the rest of the crew. The pilot is Shubhanshu Shukla of India, and the mission specialists are Slavoj Uznansky from Poland and Tibor Kapu from Hungary. This marks the first time that anyone from any of these three countries, India, Poland, or Hungary, will live aboard the International Space Station. So we're looking at multiple space firsts happening simultaneously with this single mission. Once they reach the station, the crew won't just be sightseeing. They have a packed schedule with approximately 60 different science experiments planned during their 2-week stay. After completing their mission aboard the ISS, they'll return to Earth in the same Dragon capsule, splashing down in the Pacific Ocean. Well, what an exciting collection of space stories we've covered today. From Ispace's second attempt at making history with their Resilience moon landing, to Russia's plans to bring AI aboard the ISS, to that fascinating discovery of water ice around a young star that gives us a glimpse into how our own solar system may have formed, and finally the upcoming AX4 mission that will make history for 3 different countries at once. This has been Astronomy Daily. I'm Anna. Thanks so much for listening. For all our previous episodes, head over to astronomydaily.io, where you can catch up on anything you might have missed. And if you enjoy the show, please subscribe on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. Until tomorrow, keep looking up.